Hello and welcome to this video on the ICND1 series. In this video, you will learn about three things. First, you will learn about Cisco networking. Second, you will learn about devices that are used to connect to Cisco networks. And third, we will talk about cables and speeds. So let's get started. So first, what is computer networking? Computer networking is the process of communication between devices in order to exchange information. In computer networks, there are basically two roles. So you have the server role and the client role. A server on the computer network is anything that has information. So let's say this is our server. Our server could hold information about emails, about printing files, things like that. And the client is anyone that needs the information. So this is a client. Now the client could be anything like phones, tablets, PCs, laptops that need access to a server. So for instance, if you want to access google.com, the client requests the information from the server and the server would return that information and the Google page would load. So that's how it works. Now in between the client and the server, we have the network, and what we are going to be exploring all through this series is how to make the network work. So how does Cisco come into all this? Cisco is the largest industry provider for computer networking. So industry equipment like routers, switches, firewalls, and things like that are manufactured by Cisco, and Cisco is the biggest player by far. Not that they didn't have any other competitors, but they are the largest industry player. And once you are a Cisco certified professional, it's easier for you to work on other devices, and that's why the certification is very important. So what devices does Cisco make? As far as this series is concerned, we will be looking at two major sets of devices, which are the switches and the routers. So let's explore some of them in detail. Switches are used to connect devices together on a network. The first diagram that you can see here is the diagram of a switch. This is the logical symbol for a switch. On a Cisco network diagram, this is what you would see a switch has been represented as, but physically, when you buy a switch, this is what it looks like. And switches are used to connect devices together using cables. So when you want to connect two devices together, you plug the cables into this box, and then they can communicate together on a single network. So by default, a switch is a single network. Now, let's look at some history here. At the beginning, we had things that were called hubs. They were used to connect devices together, but the problem was when two devices are connected together in the hub, things usually went fine. Once you connect the third device, we started having collisions. Because when device A is trying to send things to device B, at the same time device C is trying to send things to device A, they collide in the hub, and that doesn't help the network operate efficiently. So switches were invented to divide the collision domains in order to ensure that devices can communicate together without collisions. What's a router? A router is a device that is used to connect multiple networks together. So the key here is to remember that for your router, it is more than one network they are connecting together, while for a switch, it's just a single network. Now, this is the logical symbol for your router as we have seen before. Now, what are these last devices that we have here? They are called access points. So what happens if you want to connect something like a phone to your network? A phone doesn't have cables that you can connect to the ports of the switch. So what happens is you connect wirelessly, and access points are used to create wireless networks. And these are pictures of Cisco access points, and this is a logical symbol for the access point. You should note that in this particular series, we are not going to be exploring wireless because this has been taken out of the ICND1 series, as we mentioned in the introduction. So we are going to be focusing on switches and routers. So now let's look at one other thing before we conclude this particular video, and that's the cables that are used to connect devices to the network and to connect devices together. The first kinds of cables we are going to be looking at today are the copper Ethernet cables. There are three things you need to know about copper Ethernet cables. So the first is that they use electrons to transfer information. So an electron could be zeros or ones. Second is that their speed varies. It could be 10 megabits per second, it could be like 100 megabits, and it could have like 1 gigabits. Now, a bit is the state of the electron, whether it's 0 or 1. So when you have 10 megabits, that means you can transfer 10 million different states of the electron. That means you can transfer loads of information. Similarly, if you have 100 megabits, you can transfer 100 million states of information. And when we have 1 gigabit, you can transfer 1 billion states of information. The next thing you need to know about the copper Ethernet cables are the categories of the copper Ethernet cables. So for the categories, we have things like Cat3, Cat4, Cat5, Cat5e, Cat6. Now, these are increases over the years of the quality of the cables. The increase in the category of the cables is an increase in the quality. So typically, if we need to get any kind of cable right, now you should be looking at the Cat6 cables because they have the best quality. You can easily make this copper Ethernet cable yourself by just getting the connectors and buying the cables and trying to crimp them together, or you could just buy them. They are readily available and they are pretty cheap. Now let's look at fiber cables. They are almost in the same family with copper cables, except that one major difference is the fact that they use light, and light is a lot faster than electrons. So by default, we can achieve faster speed with fiber Ethernet cables. So two things about fiber Ethernet cables is that they have faster speed and they have longer distance. In copper cables, we have a limitation of 100 meters, and then you need to introduce a repeater in order to have a longer distance. But for fiber cables, you can go loads of miles without needing any repeater, and if you want to introduce another repeater, you can go a lot longer amount of miles, and the fastest speeds start from about 1 gigabyte, and they go all the way to tens of gigabytes, such as 40 gigabyte and beyond. And most times, the speed of the fiber cable is actually not limited by the fiber cable itself, as much as it's limited by the device that the fiber cable is connected to. So, for instance, if you have a server that's being connected to a router and the server only supports 1 gig, even if the fiber cable supports 10 gigabytes, the main fact is the server only supports 1 gig. The maximum amount of information that you can transfer will be about 1 gigabyte. Now, these types of cables are probably the least common because they are slowly being phased out, and they are serial cables. Serial cables. They were popular years ago, but they have really become less popular because a lot of advancements have been going on, and most serial connections have been transferred into parallel Ethernet connections. But what you should know about serial cables is that they're used mostly in voice implementations and to connect devices together so you can connect two routers together using the serial cable. A serial cable is very slow compared to other kinds of cables. You could have a serial cable as low as 64K. You have higher speed like 256K and things like that. When I say 256K, I mean 256 kilobits. I will talk about that in a second. So we use serial cables for voice implementation. That's why you have T1 lines, E1 lines, and things like that. In most of this series, actually we will be dealing with the Ethernet cable, but from time to time, you may have to use the serial cable. So we will talk more about that in a minute. But now let's talk about the speed. Now, speeds are measured in bits and bytes. You should know the difference between a bit and a byte. A bit is a binary digit, and it could just be 0 or 1. On the other hand, a byte is 8 bits. So when you have 8 bits, you make a byte. It's really a source of confusion when people measure things in bits and in bytes. For instance, your ISP gives you your speed in bits. So you can get a link from your ISP like 8 megabits per second, but when you're downloading most times in your Internet Explorer or your other browser like Firefox, let's say, is downloading in bytes. So you get the system saying 1 megabyte per second, and you keep wondering, why does the ISP say that I'm getting 8 megabits when I'm actually getting 1 megabit? It's because it's not 1 megabit, but it's 1 megabyte, and so that's the difference. You need to figure out that difference so you don't just go calling your ISP and trying to give them grief when it's not really their problem. So in this series, we looked at what computer networking is, we looked at the devices we have on computer networks, and we talked about wires and speed. I hope you have been able to learn something from this video, and I would like to thank you for watching.